Okay. So Hagar the Horrible is talking about rust or something up there. I'm not sure. But rust is kind of interesting. I mean, it's all over. And it's really expensive if you don't watch it, right? I mean, how expensive is one of those ships? Millions and gazillions of dollars, right? You don't want them rusting. How do you stop it? It's going to be in the water. You can't take those things out and dry them, right? So what they do is they attach these silver nodules all over the place. Okay. All they are is they're called sacrificial anodes. So instead of having the boat be an anode, you have the metal be the anode. The silver hunk of metal. We'll talk about exactly which one it is next time. But rust is a electrochemical reaction, and the boat itself is the anode. And you can kind of see that in the reaction here for rust. See how the iron solid goes to Fe plus 2 into electrons. So it's the anode. It's getting oxidized. So it's dissolving kind of, right? And then you need a cathode, something to react with the electrons. There it is. Thank you very much. The oxygen in water acts as the cathode. Okay? And rust occurs until all the iron's gone. You're going to see this a lot in the homework, and I think it's kind of confusing. They say, what's the cell potential? Okay. Well, what's the cell voltage? What's the electromotive force? What's E cell? It's all the same thing. It's all measuring the voltage of the cell. Now, how do you measure voltage of a cell? You probably use... Hi, what was that? Probably use a... What meter? Voltmeter. Yeah, so, Mara, you hold this thing. Let's turn it on. Okay. You hold it up so people can see the number. Jasmine, I'll hold the battery. Okay. So, this battery should, if it's new, have how many volts? You ever playing with these guys? These rectangular ones are always 9 volts. Yeah, I got to read the small print, but it's 9 volts. So Jasmine, take those prongs there, put one on each terminal, and see what it says. Does it read 9? What does it read? 8.5, so it's kind of dying, right? Is it positive 8.5 or negative 8.5? I can't. It's positive 8.5. Okay, now what's going to happen if she switches the probes around? It's going to what? Try it. You guys don't know? Negative 8.5. So you get the same voltage, it's just change sign. That's why they have that convention of which half cell is always supposed to be on the right-hand side. Anode, right? The one on the left-hand side is supposed to be the anode. That way everyone's going to read the exact same sign. Okay? So you build a cell, have an electrochemical cell that works, and you can separate those two half reactions into two half cells, have a little wire and run I don't know, you could run a light or do some work. Well, this how much work can you do? There's an equation for it. W max is the maximum work. I guess you should read the question. Find the maximum electrical work when 45 grams of silver is produced in a voltaic cell with EMF of 1.15 volts. So it's producing a voltage. I guess it could be a reaction inside a battery, but it'd be really expensive involving silver, so it's not very practical. But it's a reaction, and it produces some silver, and you want to see how much work it can do. What are the units of work? Summer, what are the units of work? Yeah. It's odd. To me, it's very odd. Work is force times distance. So technically, work is a Newton meter. Work is the same as energy. Energy is work. Work is energy. So that means work should have units of joules. So that's what this is in. Work is in joules. Big J. Okay, so there's our equation minus NF E cell. Well, F is, whose constant? Starts with an F. Faraday's. 96,485 big C all over moles of E minus. So I give you all the constants and things, but we have to know how to use them. The E minus probably represents what? Ramiro, what's an E minus? Electrons, yeah. So in a mole of electrons, you have 96,485 C. What's C? Jessica, what's C? Big C. Again, it's another thing that you have to take really general physics to answer. But electrons have a charge. Anything that has a charge has the big C. It's the amount of charge. Coulombs. Coulombs. C-O-U-L-O-M-B-S. It's more than you need to know. But you can name a kid Coulomb. Kind of a cool name. Like isosceles. Okay. Remember Seinfeld had that. Okay, E cell. So the number we're going to use for F is 96,485. How about E cell? In that question, what would you use? 1.15 volts. Remember how it gets confusing, man, because they can say E cell, they can say EMF, right? All these guys. So it gets kind of confusing, but it's always volts. So that's kind of, it's not so bad. So we can get the work. We are just missing N. Okay, here it is. How do you get the N? Hint, Albert, N is the number of moles of electrons involved during the reaction. It can be found using an appropriate half reaction. Okay. So let's see if we can, okay, solve the problem. Fine. W max minus N F E cell. So we know what F and E cell are. We got to get that N. Found using an appropriate half reaction. N has to be moles of electrons. Lauren, can you see what we need to convert? We need to end up in moles of electrons. We need to convert what to moles of electrons? The 45 grams of silver. So all we need to convert 45 grams of silver to moles of electrons is a what bridge? Mole bridge. It's going to be a funky mole bridge because it has to have electrons in it. Has to. Well, the only type of reaction that has electrons in it is a half reaction. Right? So there must be some half reaction we can write that's going to involve silver solid and electrons. Victoria, what half reaction could we write? What's that? Yeah. There's one. We could write Mg going to Mg plus 2. But that's not going to really help us because they didn't tell us the grams of Mg. It would have. If they would have said 45 grams of Mg. Oh yeah, we're going to need molar mass. I mean, there's a lot of right answers in. We're going to need molar mass. That's kind of ahead of us. Yeah, that's our mole bridge that I was looking at. 2Ag plus going to 2Ag solid. But it's not quite balanced. Electrons to which side? The most positive side. And two of them, right? Because both sides are 0 then. And electrons the most positive side. So here's our mole bridge Half reaction, we got it. We're going to need that. Let's start out with those 40, whoa, I'm running out of space here. Let's start out with those 45 grams of silver times, we want to end up, when we're all done, with moles of electrons. Okay, what would you do first? AJ, what would you do first? Convert it to moles, and the molar mass is 107 point what? 86. Oh, that's good enough. Okay. We're in mole. Eric, we're in moles now. Yeah, how would you do that? It's 2 to 2. See what he's looking at? He's looking here. He's looking here. 2 moles. Silver. For every 2 moles. Negative. We'll have it. .45 divided by about 0.417 or so. That's what I got. Now we can finally get our final answer here. Finally get our final answer. Minus 0.417. 96,485. What was E again? Thanks. 1.15. Did you get an answer? 46,000? Anybody else get it on 46,000? Okay. It's negative too, though, isn't it? 260. Negative. And what units do I have to put on that? 269. Joules. Make sure you put that on there. Okay. Let's see if I can confuse you a little bit here, Alyssa. Did this make sense first? Alyssa, did you follow what we did? Okay. Why did we pick, why did we write 2 electrons, 2 Ag pluses, and 2 Ags? Because it really should be, like half reaction, it would be 1 E minus and 1 Ag plus and 1 Ag solid. Right. Would it matter? Right? Because it seems like, oh man, it seems like there's something to memorize here. Right? Why not? See what I'm getting at? Why would it not make a difference? Yeah, it's the mole bridge. It's a ratio. Who cares? So you don't have to worry about it. As long as you wrote a balanced half reaction, you don't care. It's not always going to be 1-to-1, but the point is just write a balanced half reaction. Okay. Now here's some real power of electrochemistry. A big goal of all this science in my mind, again, is to be able to predict, and predict very, very well what's going on around you. So we can use tables of standard cell potentials to actually predict these cell voltages instead of actually hooking up a voltmeter to it. Okay? And all we're going to do is figure out what, well, I guess you have to make it special first, right? All the concentrations have to be 1 molar. Temperature's 25. Gases and 1 ATM. And then you can get E cell. What's the little 0 here for? Standard, just like delta G. Remember sometimes delta G had a superscript 0? It means standard. Same thing here. It means standard. Okay. So here's our equation to get it. So we're going to find the half reaction for the cathode. It's half reaction. Find the half reaction for the anode. Right? Where do you find these half reactions? In the table. You just got to find them. And let's add them up. Except there's a trick. The trick is dang, I have this half reaction with bromine, for example. But it's actually Br minus is on that side. And the Br2 and 2E minuses are actually products. It's switched. Well, all you got to do is just do what to this then? Switch the sign. So if you switch a reaction, you got to switch the sign. So they're not going to give you two tables with one like this, the other one all of them flipped. That's kind of redundant, right? So they're going to give you one table, and if you flip the reaction, you got to flip the sign. Okay. Let's try some of these here. So I'm giving you the table. You don't have it. Right? I just added that about 10 minutes ago. Use a table of standard reduction potentials, and there it is. If you want your own table, just go to the next class period. Day 34B. There's one right there. But use a table of standard reduction potentials to obtain half cell potentials for each half reaction below. Okay, Monica. I think it's showing up. What is the half cell potential for A? Yep, it's in there. I don't have to scroll or anything. Has to be for nickel plus 2. Do you see it? Yeah. Isn't that it right there? She's in it, right? This one? Does everyone agree? So you'd write negative 0.25 V. It's a V because we're talking about E0 numbers, right? Okay. Nickel solid, Vanessa, going to nickel plus 2 electrons. Yeah, it's positive because it's flipped of what's in the table. If it's flipped from what's in the table, you have to flip the sign. Okay? Okay, Mari? Do you see what we did to get C? What C did is C flipped reaction in A, then it multiplied through by 3. Right? Why is Eric right? How did you know this? Yeah, it's hard to relate to. The word potential and anything with electricity is really hard to imagine because you can't see it. It's all just abstract. But you do have a feeling for something like density. At least I do. Right? If I take this stuff, find its density, right? There's juice or something in here. So that means that, or something maybe, right? Jasmine. Okay. But anyway, there's something in there, right? That's mostly water, but it's got something mixed in with the water. So the density is probably going to be a little bit bigger or a little bit smaller than water's. Since water's got stuff dissolved in it. It's a little bit bigger, right? It's got water and some other stuff. What's the density of water? 1 gram per mil. So this is close to 1 gram per mil. Probably a little bit higher because there's stuff in there. Okay, and now whatever she had, she fills it all the way up to the top. More stuff of the same. Did the density change? No. No, it's the same stuff. Same with electricity and potentials. It's the same, right? It's okay. Because it's like that mole bridge idea. It's the same ratio. Okay. So our answer is what then? 0.25 or negative 0.25? Positive 0.25. Okay. See if we can do some of these now. Find the overall cell reaction, N standard EMF for the voltaic cell. So let's do cell reaction first. Find the overall cell reaction. Mari, how are you going to do that? Okay, so make the reactions. What reactions are you making? if we use the terminology. Oh man, Anno, that's good. That's more than I was looking for. I was looking for half reactions, right? She's writing. Oh, did you? She's writing the half reactions. She was going so fast. Did you hear her? She said Ni solid goes to Ni plus 2. Right? I'll finish it though. How many electrons, Mari? To which side? Yeah, to the product side. And then we've got the silver one. Ramiro, what's that balanced half reaction going to be? Yeah? Okay. Now we have to get an overall cell reaction summary. What would you do now? Good. Why do you multiply the bottom one by 2? Yeah, get rid of those electrons. Right? So, got my nickel, got my 2 silver ions, got nickel 2, and 2 silver solids. Okay. Jasmine, how about the standard EMF? How are you going to find standard EMF? What are they looking for? Yeah, that's now it's E cell, but it's standard, so it's technically E with the degrees thing cell, right? E0 cell, right? And that was E0 cathode plus E0 anode. And actually, we don't even, now Mari told us which one was the anode, and she was right, but we really don't care, because we just look them up in the table and write in the numbers. So what I like doing is I like writing the E0s right here and get my answer. Okay. So if you find that nickel one, Jessica, you don't have a table. Go to day 34B. Yeah, the following, find it? Yeah, go to day 34B. Find the nickel solid going to nickel plus 2. Oh, didn't we have that earlier? Nickel solid going, right? Let's have her find something else. Because, right, nickel solid going to nickel plus 2 is 0.25 volts. Oh, you know how to shut those off? I figured it out. It took me like an hour to figure out how to shut those off. I mean, imagine everyone at that instant in time driving down the road and everybody's phone at the same time. It's the stupidest thing, right? Oh, it's crazy. Anyway. Yeah, let's ask Jessica about 2 silver ions going to 2 silver solids. Two silver ions plus 2 electrons goes to 2 silver solids.
It's not in the table. Oh, yeah.
It has to be in there somewhere. Why do you guys say 0.77?
Because they're looking at the...
That's iron. Yeah, it should be 0.8, right?
It's not in, for some reason, the numbers are different on there.
No way.
Yeah. Like the nickel one is different, that chart.
I just saw it. Here. It's 0.8, right? Everybody agree? Notice the 2, you can multiply everything through by 2, by 3, doesn't matter, it's still 0.8. That's about, what, 1.05 volts. So that's our E0 cell. And here's our overall reaction. Okay? Hmm? Yeah, they're both positive, so we just add them up. All right? 0.25 plus 0.8. You okay with that? Okay. So you should have a good idea then. See if you can work this one out. You got a couple left. See if we can work them through. What's the maximum work? Okay, I'll pretend this is a quiz. I'll write down everything you're going to get for the quiz. I'll write it up here. Okay. So that's everything you're given. What maximum work can be obtained from 28 grams of tin in that below cell if the EMF is 0.55 volts? Good. I would do what a lot of folks are doing. What a lot of folks are doing is they're writing down that equation you're going to need. And that just guides you to everything you need to find. It's not 1-to-1 though. Right? 1 to 2. 1 mole of tin for every 2 moles of electrons. Your mole-bridge ratio is not 1-to-1 in this one. Yeah, there's 2 moles of electrons for every 1 mole of tin. Yep. So you know what those two are. Just got to pick the right half reaction. So Eric, what's the molar mass of tin? Thank you, sir. So AG, how many moles of electrons did you get? Oh, okay. 0.47? A lot of people are getting 0.47. Okay. Shouldn't be so bad after this now. Monica, what did you get for a final answer? Well, I mean in scientific notation. 2.5 times 10 to the 7? Anybody else get 2.5 times 10 to the 7th? Oh, I quit on you. Right here? For 1 mole SN for every 2 moles of electrons. So it's about 2.5 times 10 to the 4th? I lost my pen again. I don't know why it quits on in this class only. That's sad. And the units are joules. Right? Oh, that's easy. All right. Do this one and we can call it a day. Find the overall cell reaction and standard EMF. Died on me. Small block. It may not be safe to look at the solid. It will always work if you look at the electrons. Because the electrons in that table, all those electrons are always on the reactant side. So because that solid isn't going to always show up on the reaction side or product side, I don't think. It might. It might. You know what? I don't know.
Actually, I think, like I said here, that's a solid. It shows the solids on the solid, right?
So your solid never shows up on this side.
Yeah, so I guess you can think about it that way too. The solid's on the right.
Yeah, there's solid over here. So it doesn't work. The solid shows up on both sides. So you have to go by the electrons, I think. You have to look it up in the table anyway. So, anybody get a final answer? 0.3?
These numbers here are different than the ones here.
Well,
So I don't know if it's
they should be really close.
Yeah, it's really close. I got 0.30, you should have 0.3.
Yeah, same. So folks are getting like 0.3 volts. To get the overall cell reaction, how many electrons were you canceling? 6. If you're canceling 6 electrons, you're doing it right.
I got 0.3.
So 0.3, 0.33, something like that works. Yep. Alrighty. So it's Friday. Have a good day. Yep. No, next week I'm hoping.